Okay, hi everybody. I would like to talk about our favorite distributed system of all, Kubernetes. So this is regarding a project I worked on some months ago where I wanted to sort of have an easy way to bootstrap Kubernetes clusters. Uh, so right now, if you think about like, let's say you want to try out a new version, or you want to try out, you want to just verify that your manifest is right. It has the right syntax, for example. Uh, you can provision a cluster from GKE or Azure or all those things. But again, the problem is you do not have full control over it. Full control as in you can only choose from a limited set of versions. You cannot choose whatever version you want, right? The second thing is you probably cannot SSH into the master because on GKE at least the master is not accessible to the user. So that's that. You cannot also change flags very easily. So for example, if there's a new feature flag on the master in the new version, you want to change it and try it out, you cannot do that using the you cannot do that using the Kubernetes clusters as a service feature on all the major cloud providers. You have various other options to bootstrap your own cluster, like Kubespray is one, and I think there is more like cops and all those. But they again have like they are very complicated. Like I used to try them to bootstrap clusters, but Kubespray, for example, has support for all the cloud providers with all the various operating systems and all the different operating system versions, all the distros and all those things. And there was no easy way to sort of just add a new node or just change a flag. So this is what Devkube helps you do. It basically is a cluster bootstrapper, but it's very simple. What it basically does is it allows you to specify the number of nodes that you want. Uh, and you can add nodes after the initial bootstrapping. Let's say you start with 4 nodes, you want to go up to 5 nodes, you can do that. You can change the flag on any of the component. You can change the version on the fly. So you can choose from the latest version, some old version, whatever you want. And you can use this to uh, run your normal workloads in your integration environment. One more feature I think which is important and which sort of makes Devkube interesting is, let's say you're developing Kubernetes. So if you're contributing to Kubernetes and you want to try to test your changes, right? So let's say you're working on the scheduler and you have a change. Now you would want to run it on a real cluster and see how it behaves, right? Uh, so what you can do with Devkube is you can run binaries of your choice. So I'll show a demo wherein you can point Devkube to the location where the binary is, right? So you can upload your binary to S3 or Docker Hub, and then you can point a Devkube there, and you can run the. So these are all Ansible playbooks. So you can run the Ansible playbook, and you'll be able to sort of deploy your own scheduler or whatever component that you wrote onto your real cluster and sort of see how it behaves. A very common use case I have used is, if I want to understand some flow, I might just add some log lines, for example. Uh, I mean, that's a very basic one, but yeah. So I think this is like a very good solution uh, to set up a local dev environment for Kubernetes development, right? Not deploying apps to Kubernetes, but actually developing Kubernetes, changing Kubernetes code. So I think this also is a very robust local dev environment setup for that. Okay, so that's Devkube. These are all the project, uh, like what we want to achieve in this project, right? So I'll very quickly walk through the major components in the control plane and the worker plane for like people who do not know. Uh, Kube Controller Manager has all the reconcile loops. So the Kube Controller Manager runs all the reconcile loops for all the core apps, like core objects in Kubernetes. The scheduler basically chooses what node should a particular pod go to. kubectl allows it to talk to Kube API server. That's more of a user level component. etcd is the data store where you store the entire state of the cluster. And on the worker side, we have kubectl again can be used to talk to Kube API server. Kube proxy is basically used to implement the IP table rules, right? So whenever you create a service, for example, Kubernetes in the default implementation sets up IP table rules to implement the service abstraction. So all those are set up by kube proxy. The CNI plugins are used to implement the CNI interface that Kubernetes follows. Container D is basically a manager for runc. So runc is what actually runs the containers on the host. It starts and stops the processor, for example. Container D is sort of a high level abstraction on that, and it manages the actual software. CRA-CTL is used to sort of do Docker PS sort of stuff. It talks to CRA compatible runtime, right? So it talks to containerd runc to sort of get a list of all the containers that are running on the system, for example. Kubelet basically manages the pods on the node. So by manages, it just sort of starts them. It talks to any it talks why the CRA interface to a CRA compatible runtime and starts the pods, for example. Right. So these are all the major components that you need to have in a cluster to sort of have a functioning cluster. One important sort of thing is, and we'll see this when we deploy a cluster, is the majority of the work, right, when you sort of try to bootstrap a Kubernetes cluster, is managing the certificates. Apart from that, it's just downloading binaries and setting them with the right flags and sort of starting them, right? The majority of the work is just trying to get the right certificates in place. So yeah, that is the public key. So yeah, the basic idea here, which is interesting to understand, is in a mutual TLS setup, which is used to talk between all the internal components, right? You have the API server and let's say the scheduler. So all the conversation between all the components is via mutual TLS. So what you can do is you have a private certificate and a public. You have a private key and a public key. You can sign something using the private key and then use the public key to verify that that is indeed signed by the private key, right? But then you need to know if the private key is actually belonging to somebody who says it belongs to them, right? So certificate is a data structure that again binds the public key to an entity. So certificate basically has the public key, and then it says, and that certificate is signed by one more by somebody who you trust, right? So if it's, for example, signed by a root certificate authority, which you trust, then you can say that, okay, whatever the certificate says the public key is, that is indeed the public key for whatever entity the certificate says it is for, right? And so you can establish trust that way. Yeah, I think now we can sort of jump into the code. So actually, I'll bootstrap a cluster and show you a demo of how it works. I have an account on this cloud provider. It basically works on all the cloud providers. I tried it on AWS, GCP, and Azure as well. So I'll create droplets. Droplets are VMs, EC2 instances, for example, right? Let's say this. I'll use Bangalore. This is for the internal networking. Let's say we'll make a 3-node cluster. So right now we'll just spin up the instances. These are bare Ubuntu instances. Devkube only supports Ubuntu right now. And this is sort of the idea to make it as simple as possible. We don't want to handle all the intricate complexities of supporting all the different operating systems, right? Variants of GNU Linux. So once the nodes come up, what we need to do in Devkube is enter the IPs there. So I'll just wait for this to come up. Right. So we have one. So now one more assumption that Devkube makes is the node 1, then the names have to be this, and node 1 is the master and all the other nodes are the workers. Right now, I do not support, like the project does not support multiple masters, but that's a small change that we can make. Anyways, right now it's a single master system. So we just have to write the public IP here and the private IP here. Now, this is able, like you can automate this if you use something to bootstrap the infra, but to keep the scope of the project simple, I have not implemented all this. Because like in a real world scenario, you would rarely uh, change the masters and all those things. Right. So right now we have added the public and the private IPs for all the three nodes, and now uh, I'll walk you through what Devkube does as the Ansible playbook works out. Yeah. So you just run this. Actually, yeah, before that, you also have to give the version that you want, right? So for example, you have to give the high level settings that you want for the cluster. So these are all okay settings. You can change them based on how many pods you want to run, how many nodes you have, and all those things. And you can choose the version. So let's say we want 118.4, right? You can choose whatever version you want. Uh, so so once you have that, you can just play, and I'll walk you through the various steps that the playbooks do. So right now we are just sort of making sure we are able to reach the nodes. We are generating the root CA, and then these are the certificates for us and also for the API server. So right now we are so we are making the certificate signing requests and then using the root CA to sign them to create the certificates uh, for like the API server. So from the root CA we also create one more pair of CA, uh, and then the admin key, the keys for the scheduler, the keys for the kube proxy, for example, the nodes. Each node has its own key, and then now we download the master node binaries. So they include the API server, kube scheduler, all those things. These are skipped for the worker nodes, but here they are being downloaded for the master node. Right, so we are downloading the version that we specified, 118.4. So yeah, API server binaries downloaded, controller manager, kube scheduler, all these are downloaded. So I mentioned how you can sort of change this to download your own binary, right? Actually, let's stay here and then I'll show that. So now we are moving them into the right places, making the right directories, moving the certificates to the right place, writing a systemd config for each node, for each binary, right? Each service. And now we have HCDs online. Yeah, now we are reloading the control plane using systemd. After 10 seconds, everything should be up on the master plane, and then we'll go ahead and deploy all the components on the worker plane. So yeah, we have the master plane ready. Now we will deploy the worker nodes. Right. So here we are downloading the kube proxy, CNA plugins, runc, all those things. So again, like the entire work, if you bootstrap a cluster is making sure the certificates are in the right place and then downloading the binaries and setting the right flags on them. So once this is done, I'll show the systemd files for each component and how easy it is to change flags, for example. Right, we are moving run C to the right place. Devkube also adds two components apart from, like, it does not add anything else. It just adds the Flannel CNI plugin and the CoreDNS for the DNS thingy. So DNS discovery and the CNI plugin is set up so that you can just deploy your pods directly. You don't have to worry about that. And of course, you can change. These are all just Ansible playbooks. Okay. So now the cluster should be ready. We got the version that we wanted, 1.18.4. And it should take, in some time it should be ready. Okay. So now the cluster is live. You can deploy, for example, I'll just deploy a non-trivial application. And then show you a demo of sort of, I'll deploy Argo City, which is a CNCF incubator project. So now, so the pods are scheduled onto the nodes. They are working fine. They're able to talk to each other and all those things. I'll just change the service type here so that we can talk to it. Right, so it should be. I'll just show the login screen here to show that it's actually indeed deployed. So the certificate is self-signed. So yeah, so Argo City is deployed onto our cluster. So we have a running cluster right now. I'll just show the features which I spoke about, right? Now, let's say we have this running, but now we want to add a new node. So I'll just create one more node. Right, so we'll add a new node. We'll change the version of the Kubernetes that is deployed, and we will also change some flags. I'll just wait for this to come up, and I'll show you sort of some of the code there. In the meantime, I'll show you how you can change this. So for example, these are all the locations where you will find the binaries. So if you have your own, let's say, API server that you want to deploy, just change this to point to wherever your API server is uploaded. And then Devkube will download that and use that to bootstrap the cluster. Right, so we want to add a new node. This is 4, right? And we want to, right, so we want to add a new node. We also want to change the version to, let's say, 5. That we can do, but a special flag is the latest. So what this will do is it will deploy the latest Kubernetes cluster. And let's say we want to change a flag, right? Let's say we want to change the flag on the kubelet. So let's say we want to change the verbosity to P2 here, right? Right. So we changed the flag. We added a new node and we changed the Kubernetes version. And now we can again just run not the entire cluster, but just the worker planes, the workers, right? So if we do this, it will just run the playbook for the workers. Yeah. So now what will happen is our workers will be the latest version, but our master will be 1.18.4. So this will again add a, like deploy all the packages, like download the binaries, move the certificates. Actually, before that, I need to generate the certificates for the new workers. Sorry. So before that, let me do a they yeah, we need to run this to which generates the certificates, because we need certificates for the new node, like uh, all the worker components, worker binaries that will be deployed onto the new node. They need this certificate so that they can join the cluster and talk to all the like talk to the API server, for example, right? So this will generate new certificates. Yeah, we generated certificate for the fourth node as well. Right, now we can run the worker thingy. So now it will move all the certificates in the right place and then deploy the worker with the right certificates and binary versions and all those things so that it can join the cluster. We need new downloads again because we changed the version. So earlier it was 1.18.4, now it's the latest version. This time we are doing it also on the new node. So this is like all the three worker nodes, right? Uh, I'm looking at the chat. There's a question. It says, in Ansible playbook, what kind of Kubernetes install method have you used? Yeah, so I have specifically not used like an install method. So for example, you can use kubeadm to bootstrap a cluster, but I wanted to keep this as simple as possible, so that you can just go to the Ansible playbook and change something if you want, right? And you can change, like, the entire thing is very bare bones. And and I've just used the Ansible, I think they're called modules, right? Where you can download a particular binary from the internet. You can move it at the right place. You can generate a file, for example, using the variables and all those things. So now we have the latest cluster and the last node should be ready. In the meantime, I'll show you that this is indeed the latest version of Kubernetes. So if you go to commits, yeah, so this is like a 5-hour old cluster. And this is, the old nodes are ready with that version. The new node, actually, let me try to run the worker thing again. It should be fast this time because the binaries are downloaded already. Yeah, so it could be a bug in the master, which sort of is unlikely, but it could be. And like in the E2E test that we do on the Kubernetes pipeline, I'm not sure if they test for a new node joining with a different version. There the cluster is bootstrapped and sort of everything is run there. But yeah, the flag should have been changed as well. Now I'll just walk through some of the code. The plays again, like there are 4 different playbooks, which is to generate the root certificates and then run the workers and the masters. They're all very simple, straightforward Ansible playbooks where you can just sort of run the shell module, run the get URL module to download a binary and move it to the right place. So there's no tool that I'm using. It's just a very raw Ansible playbook. In the meantime, I can show that this is indeed deployed. So now I guess I can SSH and sort of see. Yeah, I can show you one thing, which is this is one more advantage where you sort of have the whole system, right? So you can plugin is not initialized. Oh, I think I know what's happening. So the plugin thingy might have been in the control plane, and it ideally should have been in the worker plane so that you can download the plugins here. Yeah, I think I'll have to look at this. This might be a bug in Devkube, but ideally, I think one thing is, let me just change the version back to 1.8 and run this one more last time, and I can take questions while this runs, if there are any. So Rajiv, are there any questions?
Yep, there is one question in the chat asked by Rangaswamy.
So, hi, this is Ranga, and I think Darshan just answered that. But I have one follow-up question. The nodes which are joining the master, right? They need the node token. So where is that stored? Is it stored in temporarily in some location?
So in the bootstrapping process that I wrote, right, you just have to sort of give it the right keys, and they are able to discover because the internal network is open. And then let me remember what I did when I wrote this, right? Because I just moved the certificates, and then the certificates, so the flags, right? The kubelet flag has the node address.
Correct.
And so once you have the certificate set up nicely, I think they're able to communicate in. I'm not sure how it works internally in Kubernetes. There's a request for a token, and then the API is granting that because it sees that the certificates are trusted, something like that. But I did not have to sort of do any gymnastics around storing the token or something like that.
So your Ansible playbook doesn't have the command kubeadm join or something like that, or you don't have
there's
to
no
do it?
kubeadm. There's no kubeadm here. Like I'm not using kubeadm because that's the whole problem, right? It's opaque. It doesn't allow you to sort of look at the bare bones cluster. Now this is just Ansible and shell commands. Yeah.
So in that case, you're totally not using join command at all.
Correct.
Okay, fine.
So now the 4th node is ready with the 1.18.5. So I'll have to look into why the latest one is not working. I mean, that's a little weird, but yeah. So I think that's the whole problem, right? So the join thingy, it might be a kubeadm quirk, which I do not want in, like, it obstructs understanding, right? Because in reality, if you see this project, it doesn't have to worry about it, but this might be implementation detail in kubeadm. It might be, right? I'm not sure, but that's the whole point of using this, where there's no magic. It's very simple shell and curl. So.
Okay.
Okay, any other question?
Does it also have support to have like a federation or ingress controller or something like that?
Yeah, I mean, you can, it has the Flannel CNI plugin installed already. So if you have pods on different nodes, they can talk to each other, and it has the CoreDNS deployed. So you can use DNS thingy for service discovery. So for example, you can use the service name to route traffic. It has these two things, and then you can deploy whatever ingress controller you want, right? That should be okay because the networking is set up, and then the service discovery is set up.
And do you currently use this for your dev purpose internally in Gojek or?
Oh, no, no, no. So this is like a personal project. It's not used by Gojek, or it's not related to Gojek. It's like in the
Okay, okay.
previous talk, the speaker said personal views, not related to employer, sort of that. Yeah, we
Okay,
don't use this in Devkube, like in Gojek for sure.
okay, okay.
Yeah, I mean this is like more of a. I mean the basic question I started with was what would a good Kubernetes, a good local environment for Kubernetes development be, right? Because let's say you want to
Hmm.
contribute to Kubernetes. How do you make sure your, well, like the change that you made is okay, it actually works?
Okay.
So for that, in my opinion, like you have Minikube, you have all those things, but the problem again is like it's a single node. You might not, if you made a networking change, you might not get like a real cluster thingy. And if you have workloads, it might behave differently in Minikube versus a real cluster. So here you can use this as a good local dev environment by sort of sending your binary to Docker Hub and then using it actually needs a binary. It's not deployed on Docker, the worker components. So you need to send it to S3, for example, right? And then add the URL to the download wires and then use it.
Do you also take care of all the prerequisites in terms of like installing Docker and other stuff on the nodes?
Yeah, Docker is not installed. We use like runc and container D. So the workers, the nodes that I like the instances that I bootstrap, like which I showed you, they were like normal plain instances. Okay, okay, so the fourth node is ready with the latest version, and this is the latest. I think the version changed. Yeah, I'll just answer your question. I just want to verify. Okay, so this is like 2 hours ago. So this is the latest cluster which exists in, like, which is built, right, and it's running our application. Yeah. So to answer your question, the nodes that are provisioned using the interface here, these are all plain droplets. They are all very plain Ubuntu machines. They do not have Docker. They do not have anything. They just have Ubuntu 18.04. What we do is we do not install Docker, but we install runc, which sort of, so Docker is basically runc and like some more logic around that, right? So they broke up the project into multiple various components. So this is that runtime which we installed and then use that to bootstrap clusters.
Like the Creo runtime.
No, no. So that's different as well. So
Okay,
I think
okay,
there
fine.
are, yeah. So we have the Sierra interface, and then the two popular ones are that by Red Hat, which you mentioned, and then we have runc, which is like the core of Docker. The Docker project was broken into runc, which is like, which actually implements the start and stop of the normal nodes, like the workload that you run, and then you have the manager on top of that and all those things. And then you also have a CLI to sort of get the list of containers that you're running on the node. CRI CTL. So
Yeah, yeah.
it
Okay,
basically downloads all those binaries and sets them up.
okay, fine.
Yeah. Any other question?
So, what is the future roadmap of this project that you are developed? Like, where do you
Uh,
see this going? Like,
I mean, so I mean, ideally, I wanted to sort of use this to jumpstart Kubernetes contributions, but that hasn't worked out very well. So, I mean, that's what I originally intended to do with this project, and I guess I do not have any plan. It's just a tool to sort of ultimately help me contribute to Kubernetes. I mean, that's what I thought. I do not imagine any company would be interested to use this to run their actual workloads. like use this as a self-managed Kubernetes. I think that can be done. It would probably be a better idea than using some tool which has its own logic and all those things, because this is very bare bones. You can change everything here. So I think if some company wants to use this to actually run their clusters, I think it's a better idea in my opinion than using cops, for example, right? Because there is so much code which we do not know, and I'm not sure how it works. Especially in cases where you want to add a node, for example, there might be corner cases which cops has not covered or something. But here it's just Ansible nodes, so and Ansible playbooks, so you can go and change that.
And one more thing is, can I start and stop my cluster nodes so that I can save on the running time?
Yes, you can. So you can delete the nodes and then run the
No,
playbook again.
no delete. I mean, I want to stop my VM instances and bring it and restart my VM instances.
Right. So that, I mean, that you probably don't need Devkube for that, right? So for example, here using Kubernetes primitives,
Correct.
you can move out the workload from there, go to your like your interface here, and for example, if there's an option to stop the instance to it, and then Kubernetes, and when you start it again, because we have systemd there, it will start the process, and then again because the certificates are already in place,
Right.
the API server and the kubelet interaction will give a new token or whatever it needs, and the node will rejoin the cluster.
Have you tried it?
No, I have not tried that, but I think it's a Kubernetes feature, so Devkube should not. I think the entire thing is sort of a Kubernetes thing only, right? You probably don't need a.
Agreed. So usually in Kubedium init, that thing works. I can stop my nodes and bring it back up. It'll already go and fetch the certificates the next time it goes and talks to it.
Yeah, I think I can try to do that here if there's an option. I think there is a power of option on. Okay.
Yeah.
So
And
this is turned off.
what does it also? Is it this fast even on AWS? Because DO is really fast. It took less than 5 minutes to bring up the cluster, correct?
Yeah. So yeah, this is. I mean, so basically, the entire thing depends on how close your data center is. This is Bangalore, so this is quite close from Gujarat, where I'm right now, and also how fast your instance network is, right? That will be fast because you just need to download the binaries. They're not downloaded locally and then transferred. They're downloaded on the instance. So that should be fast. I think the entire time is basically just downloading binaries. That's the majority time. And then certificate generation is usually very fast on your local laptop. We generate the certificates locally and then transfer them to the nodes.
So that's what I'm saying. So on AWS, was it the same speed, or you said you tried it on AWS also?
Yes, I tried it on all the cloud providers. It's the same speed.
Oh, okay.
Yeah, so this node is out. It's not ready, and then I'll switch it on again. It should just join the cluster.
Okay. Do you see this replacing Minikube by any chance? No.
I mean, I would not use Minikube if I want to do anything like.
That's what I'm asking. So, is this a replacement for Minikube, where if I don't want Minikube, I can have this and start working?
I think so, yes. Because this has several advantages over Minikube. I mean, you get a real cluster. The Minikube, the problem, I think, in my opinion, the biggest one is it's a single node, so you won't have the networking thing, and especially if you're a operator on the cluster, right? So if you want to try out the network, I mean, if you're an application developer, it probably won't make a difference because the network is not your concern. But if you are a sysadmin, you might not want to use Minikube to. Yeah, I mean, if I'm a sysadmin, I would definitely use this over Minikube to sort of try out the various networking sort of things. And yeah, to answer your earlier question, it is able to join them.
Yeah, excellent. So why is the master node not displayed? When it's kubectl get nodes, right? All the nodes should be displayed, correct?
I did not change anything around that. I think this could be this version, or like this is like from here onwards, it's proper a bare bones Kubernetes cluster. It's nothing to do with Devkube. So
no. What I'm asking is, see, when you do a kubectl get nodes, right?
Yeah.
Master node should also be displayed along with the worker nodes, correct?
Okay. I'm not sure why. I mean, that's an interesting question. I haven't thought about it. I can probably look into it.
Okay.
Yeah.
Okay, that's just a minor thing, probably something to do. I don't know. So because generally when you say kubectl get nodes, it should say which one is the master and
Okay.
also display which are the nodes. So that's what I'm asking. So that's fine.
Right. I think
But this is a great. It's a great work. I think it's very neat. And how long did it kind of take? Were you doing it all by yourself or like?
Yeah, I mean it's all by myself, I guess. But I took the help of Kelsey Hightower's Kubernetes the hard way. So that sort of made all the corner codes. Yeah. So then it was just a simple matter of migrating that to Ansible playbook. So you don't have to do those things manually. But what I really liked was like how bare bones it was, because KubeADM again has like all those opaque things, right? So I think yeah, it did not take much time because I had Kubernetes the hard way. Just some Ansible IP. So you have IP lists, and then you have to sort of slice, and like you have to wrangle those when you set the certs. I mean, that's the only part, I guess, which is interesting when you write the source code for this.
Okay, thank you, Darshan.
Yeah.
Are there any other questions?
Yeah.
I think there are no more questions. Hello, everyone. This is Shekhar. And